In this problem, we are being asked to determine which of the following triangles are right triangles. So we are in fact going to use the Pythagorean theorem to help us solve this problem. However, typically when we think of the Pythagorean theorem, we think of the statement, if we have a right triangle, then we may solve for a missing side using the Pythagorean theorem, which states a squared plus b squared equals c squared. However, we can also do the converse of that. So the converse of the Pythagorean theorem is exactly the opposite. If we know that a squared plus b squared equals c squared, if that in fact is true for the given legs and hypotenuse, then we can determine that a triangle is in fact a right triangle. So we're going to go ahead and do that. So let's look at this first triangle, triangle A. We have what seems to or appears to be a right triangle. We're going to go ahead and set that up using the Pythagorean theorem to determine if it is a right triangle. So let's go ahead and label our sides. We know that our longest side is this 11 feet because the square root of 115 is going to be in between 10 and 11 because 10 squared is 100 and 11 squared is 121 and 115 is in that range. So our longest side here is 11. So we're going to go ahead and label that C. And then it doesn't matter which leg we label A and which leg we label B. So to set that up, we're going to go ahead and plug it into the Pythagorean theorem. And doing that, we see that we get 9 squared plus 100, the square root of 115 squared equals 11 squared. If we go ahead and simplify that, we end up with 81 plus 115 equals 121. And when we add those together, 196 does not equal 121. And since this is not a true statement, then we know that triangle A is not a right triangle. So we're going to go ahead and cross this guy out. Not a right triangle. Let's look at triangle B. So looking at our three sides, again, it looks like it could be a right triangle. We're going to go ahead and take this 48.5 as our longest side. So we're going to say this could be our hypotenuse if this is in fact a right triangle. And again, it doesn't matter which side is A and which side is B. And we're going to go ahead and plug that into the Pythagorean theorem. And then doing that, we get 32.5 squared is equal to 1056.25, and 39 squared is equal to 1521. 48.5 squared is equal to 2352.25. And then when we add up the left side, we end up with a statement that says 2577.25 is equal to 2352.25. And since we know that's not true, then we also know that triangle B is not a right triangle. Okay, let's go ahead and look at our last one. We don't have a drawing, but we're going to go ahead and set it up just the same. We're going to look for that longest side and label that side C. So in this case, that would be side 3. This is going to be our C. And then it doesn't matter which side is A and B. We'll just go ahead and put them in order. And then we can go ahead and set it up using the Pythagorean theorem. And we end up finding out that if you square the sides and add up the two legs, you do in fact get a true statement, which means this guy, triangle C, even though we can't see it, is in fact going to give us a right triangle.